Hello everybody, my name is Mahesh Yadav, and in this video we will be dealing with three equations of motion which are actually shown in this slide and some other formulas. These are at the conceptual level only and at the level of high school physics. Once you finish the video, you can also download certain problems which will make you understand these formulas better and also deal with some of the tough problems. Hope you enjoy. So let us go over the important formulas of equations of motion. The first one is average speed equals to total distance traveled over total time. So to explain this, let us imagine that you are going to the grocery store, which is 10 kilometers from your home. Now you take a car and it takes say 15 minutes to go there. So you cover 10 kilometers in 15 minutes. You stop the car, do your grocery, say it takes half an hour, and then you come back the same distance, which is 10 kilometers, in again 15 minutes. So total distance traveled is 10 plus 10, which is 20. Total time is 15 minutes plus half an hour plus 15 minutes, which is 1 hour. So your average speed is 20 kilometers over 1 hour, so 20 kilometers per hour. Now, you have to understand that you took all the time into account. So the time you left the house till time you arrive the house. So total time you have to take. Here comes the main three equations of motions, which is valid when the acceleration is constant. And most of the problems that you do are with acceleration equals to constant. So let's go over one by one. The first one is Vf is equal to Vi plus At. Vf is final velocity, Vi is initial velocity, A is the acceleration, T is the time taken for that acceleration. Now in the second equation of motion, you see D has been introduced. D is displacement or change of position. So the equation is D is equal to VIT plus half AT square. In the third equations of motion, we see time is not there. So the equations of motion is Vf square equals to Vi square plus 2AD. You will have to memorize these equations. There is no other shorter way. Now here we just like to mention that D is the displacement which is different from the distance traveled. Distance traveled is a scalar quantity. D is the displacement. For example, if I were to throw a ball vertically up and it goes up and it comes back to my hand, the displacement is actually zero, but the distance traveled is not. In my first example, when I said that a person is going to the grocery stores and coming back to the same point, the displacement was zero. So the idea of having total distance traveled is trying to measure the effort, but definitely different from the displacement. Let's now discuss about dimension. Dimensions are also very important because it gives an interesting insight in the variables that you're trying to solve. Not only that, it helps you guide correcting the problem. Many times when I solve the problem, I often use different kind of validation, and dimension validation is one of them. So let us go one by one. D is displacement. It is measured in miles, kilometers, meters, all of which represent length. T is time. it is measured in seconds, minutes, months, years, whatever, all of which represents time, and it is given as uppercase T. Velocity is distance over time, so it is L divided by T, or L T to the power of minus 1. Acceleration is rate of change of velocity, so velocity divided by time. So it is another time divided over the velocity, which gives you L T to the power of minus 2. Let us do some validations. We will use equation 1 as our first case. The idea of validation is that each term needs to have the same dimension. You may have heard of the phrase, you can't add apple and oranges, and that is exactly true here. Each term needs to have the same dimension. Let us take 80. A dimension is L over t square, then times t will give you L over t, which is exactly the same as velocity dimension, and that is exactly the validation we expect. Let us do on the second equation. Here, VIT or AT square should have the same dimension as displacement. So let us do it for AT square. A is L over t square and t square is t square, which will give you L. That's exactly what we expect in this validation. Similarly, we do for the third equation. AD is L over t square times L, which is L square by t square. And that is exactly same as V square. And this is what is meant by the validation. Another important aspect to know is the standard system of units. It is also called SI system. SI is Système International in French, which translates to International System of Units. So the reason it is necessary is, imagine there are three friends. One is talking in miles, another is talking in meters, and yet another is talking in feet. It will not be easy to have a meaningful scientific discussion unless we all agree with a common standard units. So it was chosen that the distance will be in meters, time in seconds, obviously velocity is in meter per second, acceleration is in meter per second square. And later on you will study the mass is chosen in kg. And yet there are few more. Another aspect of these equations are that these three equations can be applied in any given one dimension. But when you are doing two-dimensional problems, you will have same set of three equations, but with different variables in different dimension. So in all actuality, you have 6 equations of motion. And when we are dealing with 3 dimension, you are having 9 equations of motions. It will become clear once you start solving the problem in 2 dimension. So till that time, you can wait. There are few more important equations of motions that you should know. What is shown below is a definition of velocity and definition of acceleration. Velocity is rate of change of displacement. Acceleration is the rate of change of velocity. This will be more clear once we do problems involving graph. Also, in problems, you should be able to figure out the velocity based on change of position over a period when the change occurs. So it will be given in a different words. you should be able to reduce it to this formula. Similarly, if the velocity is changing over a period, then you can also calculate acceleration with this formula. Another important equation is speed equal to distance by time. This we all have studied in the secondary school, and this is valid when there is no acceleration. This can be reduced from our equations of motion, namely the second one. Displacement is equal to VIT plus half AT square. Make acceleration as 0, and the expression will reduce to this formula. Another important formula is d is equal to average velocity times time. And average velocity is initial plus final velocity divided over 2. This also can be reduced from our equations of motion. Just that it is a little bit complex. Let us do that. So from the first equation of motion, Vf is equal to Vi plus At, you calculate your acceleration. And this acceleration we will substitute in the second equation of motion. And if you reduce it, it will come to this formula. You can pause this video and try it yourself. Now let us study which of these quantities are vectors or scalars. I see many of my students making simple mistakes to identify if it is a vector or a scalar, although they may know the definitions of the vectors and scalars. So let us study some of the examples. But first, what is a vector? Any quantity that has a magnitude and direction is a vector, and a quantity that has only magnitude but no direction is a scalar. Now let's see some examples. Say a ball thrown up with a speed 10 meters per second. So here, since you are throwing up, the quantity is positive. So obviously that's a direction. If it is thrown down, it will look different. The velocity will be minus 10. So that is a vector. Acceleration due to gravity. Acceleration is downward, and therefore it is a vector. Because if it is upward, the things will look very different. Similarly, for displacement, ball drops down a distance of 10 meters. So it has negative 10. Why? Because we normally take downward as negative. But there is no preference. You can take downward as positive as well. But then you need to be consistent while doing the problem. That's all. So let's look together what are certain vector quantities. Now let us take a look at various quantities that are vector. Displacement is a vector because an object could travel same distance, say to the right or left, up or down. In each case, situations are different just because the direction was different, and therefore displacement is a vector. Velocity. Velocity is also a vector because things could be moving right, left, up or down. But just from the mathematics of it, velocity is displacement over time period. If the displacement is a vector, and since we know time is a scalar, any vector multiplied by a scalar always gives you a vector, and therefore velocity is a vector. So either think of physics or in terms of mathematics, you will get a good hint if it is a vector or a scalar. Acceleration is a thrust towards right, left. Acceleration due to gravity is downward, not upward, and therefore acceleration is a vector. From mathematics perspective, velocity is a vector. Divide by time, which is scalar, should give you a vector. Now let's consider force. You think you can push rightward or leftward. The situations are different, and therefore force is a vector. But just from the mathematics, now that we know acceleration is a vector, times mass, which is scalar, will give you a vector, and therefore force is a vector. Impulse is force times time. Now you cannot feel the physics of impulse. Then look from the mathematics. If force is a vector, time period is a scalar, you multiply vector by a scalar, you will get a vector, and therefore impulse is a vector. Momentum. Momentum is mass times velocity. Velocity is a vector, mass is a scalar, scalar times vector is a vector, and therefore momentum is a vector. Now how easy was that? Now let us take a look at some of the scalar quantities. Time is a scalar. It has no direction. Distance traveled is a scalar. Think of it as number of steps you have traveled. It could be east or south. All you are interested in number of steps. So it is independent of direction and therefore a scalar. Density is mass over volume. Both mass and volume is scalar and therefore density is a scalar. Mass, as we have already discussed, is a scalar. Work or energy, this is a bit more interesting. Let us consider kinetic energy, which is half mv square. Now you know that velocity is a vector. How can you multiply vector with a vector? You may have studied that the vector can be multiplied in two ways, by dot product or by cross product. Dot product happens to be a scalar. Cross product is a vector. Since kinetic energy is velocity dot producted with velocity is a scalar, and therefore kinetic energy is scalar. Potential energy is gravitational force, which is mg, a vector, multiplied by displacement along the line of force. And there is also a dot product involved, and that's why you get mgh. It is the height along the direction of the acceleration. So therefore, potential energy is also a scalar. I hope this way of thinking will help you to identify vector from a scalar a bit more easier. So to summarize, in this video, you have learned about definition of speed, which is total distance traveled by total time, and the three equations of motion. I hope you have memorized it. Vf is equal to Vi plus At, d is equal to Vit plus half At square, Vf square is equal to Vi square plus 2Ad. And then the definition of velocity, which is rate of change of displacement. Acceleration, rate of change of velocity. So I hope this video has improved a little bit of your concepts. And if you like to see other videos, please subscribe to this channel. And do not forget to download the problem set, which is given in the link below. Thank you all. We'll see you next time. Bye bye.